kids in front of me at least that were like messing around the whole time, and the proctor kept stopping and slowing down. It just took forever.
You're going to write the parametric equations of the line through these 2 points. So let's back up and let's just write the regular, like, Cartesian equation of the line. So what would you do first? Find the slope. So the slope will be 1 minus -4, 6 minus 2. Did you get 5 fours?
Which question? Where are we at?
Oh, we're
I think you're on the
on.
homework.
Oh, wait, that's the homework. Never mind. Sorry. Nope, not doing homework yet. Doing problem 1. Same thing with different points. All right, so what's this slope? 6 minus 3, 3 minus -2, 3 things. All right, and then what would you do?
Make an equation where it's like one of those, so like 6 equals 3 over 5 times 3 plus b.
Okay, so you're using slope-intercept form. I'm going to do point slope because that's what I always do, but the answer will be exactly the same thing. So I picked that point because Cole did. So y minus the y coordinate equals the slope, x minus the x coordinate, right? And that would be the point slope form. If you got y by itself, it would be the slope-intercept form. That is not what this question says. This question says write the parametric equations, all right? So here's what I want you to think about. If I were going to graph this line, could I put a point, let's just say 3, 6. Could I put a dot at 3, 6? And then go up 3 and over 5 to get another dot?
Yes.
And then up 3 and over 5 to get another dot, and so on. So another way to think about this is to say, let's take our original point, and it could be either one. I'll just use 3, 6 because then. And I am going to add multiples, and I'm going to use t as my variable, multiples of that movement. So that movement says your y's have to go up 3 and your x's have to go right 5. So this represents, this is start at the point 3, 6, and then add multiples of 5 to the x. Isn't that what you would do? 5 to the x, and multiples of 3 to the y.
What's that like t addition sign thing mean?
Multiples of 5, 3. To keep going. T is a number, a real number.
It is? A real number? Oh, I thought you were saying like
It could be like an n.
I thought you were saying like the letter E is like point whatever.
No, that's a t.
Oh.
That's an n. But I'm using t because that's the letter we use when we write parametric equations.
Okay.
That's just a variable.
Okay, yeah.
Okay? So if t is 1, I would go right 5 and up 3. If t is 2, I would go right 10 and up 6. Okay? Now, that describes the new points on my line. So if I start right here and go multiples of over 5 up 3, I'm going to get the new points on my line, the new ordered pairs on my line. Now, if I separate this into 2 equations, looking at x and y separately, what will x equal? X will equal what? 3 plus 5t? And y will equal 6 plus 3t. These are called the parametric equations. You're looking at x and y as individual pieces, but it's the same as it's always been. You have an original starting point at x is 3, y is 6, 3 comma 6. You're going positive 5 in the x direction and positive 3 in the y direction. Now, what happens if t is a negative number? What happens if t is negative 1? Then you would be going left 5 and down 3? Is that okay? Can I go left 5 and down 3? Would that still be on the same line? Absolutely. So if you let t be every real number in the whole wide world, you will generate the entire line. These are called the parametric equations. All right, so without going through all of this, can you do the second one? Your points are 5, -3, and 6, 1. So what's your slope? 1 minus -3 over 6 minus 5. So 4 over 1. Now remember, that means that the x's are going 1 and the y's are going 4, right? So pick a starting point, doesn't matter which one, we can use 5, -3 this time, it doesn't matter. And add multiples of your slope vector. This line goes right 1 and up 4. So what are your parametric equations? X equals 5 plus 2, and y equals
1 plus 4, 2.
-3 plus.
Oh, yeah.
negative
T4.
3
I used
plus
a different
4.
format.
Yeah, you could use the other point. So Kellen says, my equations look a little different if I use 6, 1. Yes, but that's gonna be right here, right? So instead of 5, -3, he's gonna have 6, 1. Is that okay with everybody? All right, Declan,
So is T,
a real number,
and all real
and you're all real numbers. The only way you can generate the line, you need the whole line, so you need every t in the whole wide world.
So what would happen if you put in like an imaginary number?
Well, then you're gonna have eyes, and you're not gonna be in the real, you're not gonna be in the Cartesian coordinate
Cool.
plane. So, no, you're not doing that.
Yeah.
All right. Do the next one by yourselves right now. Figure it out. 4, 0, 7, 2. What are your parametric equations?
I can't hear you.
How do those look to you? Did you get those done yet?
I used all the point.
If you use the other point, which is perfectly okay, there are infinitely many points you could use. But if you use the other one, you're gonna have 7 plus 3t and 2 plus 2t. And those are both okay, because what do they both represent? The line with a slope of 2/3 going through the point, either point 7, 2 or 4, 0, which that line does. All right? Okay. Write the Cartesian form. Now the Cartesian form is your regular line. If you know the parametrics are 2 plus 4t and -1 plus 6t. So in other words, can you go backwards? Can you go backwards? What is a point on this line for sure? You know 2, -1 is on the line. What is the slope of this line?
3 halves.
3 halves.
I equals 3 halves.
So you can either put it in slope-intercept form and find your b, or you can just do point slope and say y plus 1 equals 3 halves x minus 2. All right, number 3. Is that a function, do you think?
Yeah.
Maybe.
Oh wait, no.
That's a circle, isn't it? Is a circle a function? No. So we want to find what we call the implicit functions so that we can graph that thing on our calculator in function mode. It won't graph right now because when you put an equation into your calculator to graph, if you're in function mode, y's and x's, doesn't it have to be y equals? So we're going to make this y equals. So let's start by subtracting x plus 3 squared. And then, let's take the square root of both sides. So y minus 1 is going to equal plus or minus the square root of this. And then y will equal 1 plus or minus the square root of this. These are called your implicit functions. In other words, all I did was get y by itself. All right, now let's put these two equations, these are separate equations, one plus and one minus. Let's put them into our calculator, graph them, and see what they look like. Here's what another window is. All right.
You can type in the plus or minus part.
You don't, it's two separate equations. They're implicit functions, each one is a function. I want you to type in only one at a time. Let's just type the first one in, the plus one, because I want you to see what happens when you type it in. So just type in the 1 plus version. And remember, these are called the implicit functions. Tell me, Louis, we're not going to let's get our calculator out. Let's type it in. Oh, this is what I'm learning to do. So when you type that in, did anybody get a shape?
Yeah, football.
What did you get?
Football.
Well, I only graphed the top equation, that's what I asked you to do, and all I got was the top half of the circle. So guess what's gonna happen when I do the 1 minus?
The bottom half.
I'm gonna get the bottom half. So you said to me, this thing was a circle, not a function, and you are correct. However, if I split it up and do each part separately, each part is a function, and when I do them at the same time, I get it. That's what we mean by an implicit function. Take something that's not a function and break it down into two separate equations that when you graph them together, they will be functions. I think we've talked about this before. You guys told me that's a circle, and you are 100% right. Does yours look like a circle?
It's like an oval.
Hit zoom square. And square is 5. Hit zoom 5. Zoom square. Does that circle it up for you? And I think, I'm sure we talked about this, but I'll say it again. When they made your calculator, and I don't know why they did this, but what shape is a screen?
Rectangle.
Yeah, and so everything you graph is going to get warped by the framework that you have. You have a rectangle, so everything's gonna get pulled in the X direction more than the Y direction. In other words, the hash marks on the X direction are farther apart than the hash marks on the Y because of how it's built. So if you just hit zoom square, then you'll get the actual shape.
Kellen, is your screen square?
All right, let's look at the,
No, it's right
Oh.
let's look at the, we're finding the implicit functions for this equation. All right, this one's a little tricky. Let's use our creativity. We're all on fire today because we got some good math in this morning. Remember, if we're finding implicit functions, we have to solve for y. You gotta get y by itself. This one's a little problematic because,
Y minus X squared.
Kellen says, what if I factored this? That factors. Doesn't it? And now I can square root it. So y minus x equals plus or minus 2. So y equals x plus 2, or y equals x minus 2. Now you don't have to graph this one because you know what shape is that going to be. There's going to be two lines that are going to cross each other. No, they're not. They're going to be parallel. There's going to be parallel lines. Now, so believe it or not, that represents parallel lines. If we graph those parallel lines together, the whole equation, is that a function? No, but if you graph them individually, they are functions. Implicit functions. All right, try C. By the way, equation B has a name. It's called a degenerate conic. You don't need to graph this one, but if you did, it would be another circle. This is what I got for my implicit functions. By the way, when you have this kind of stuff going on, can you square root those? No, 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 no. As soon as you put a plus sign in there, done. No simplifying. Don't try it.
I like square rooted the like up at the top. I just square rooted the entire left side.
Mm-hmm.
Could you not do
And
that?
got what?
Just x plus y plus 1.
Okay, my friend, what did I just say 30 seconds ago?
Why wouldn't that work?
As soon,
Because when you have the addition, it becomes one term.
is that a true statement, Cole?
Actually, yeah.
Okay, let's square root both sides. Is 3 plus 4 equal to 5?
No.
Okay, I know you don't believe me half the time, but I'm telling the truth. As soon as you put a plus sign into your radical, there's no simplifying. Okay, don't, minus 2, plus or minus either way. Can't do it. Can't do it.
I remember when I was a freshman.
I'm not a freshman.
Alright, stop.
It's okay, but I wish you'd listen to me, because I just said that. Okay, now,
You wish you were a freshman.
parabola. Definition. The conic sections are part of the state standards in pre-calculus. We're not gonna get to hardly any of them, but parabola, here's your definition. The set, you need to write this down where it says parabola equals. The set of points in a plane equidistant from a point and a line in the plane. So in other words, okay, one more time, set points in a plane equidistant from a given point to a given line in the plane. Now, here's what that looks like. Here is a given line, here is a given point. I want all of the points that are the same distance from here as they are from here. So would you agree one of them would be the midpoint right there? And then maybe another one's over here, so that that distance is the same as that distance. And another one might be up here, so that that distance is the same as that distance, and so on. If we put all those together, they make a parabola shape. That is the definition. The point is called the focus, and the line is called the directrix.
Which point are they? But they're not all like equally distant. Like from the point.
Okay,
Like look at the top one. It's way further than the bottom.
okay. Take this point. That distance right there has to match this distance right here.
Oh, okay.
And that distance right there matches this distance right here.
Okay.
That matches that.
That makes more sense.
It's exactly what the definition says. Okay? Now, let's look at equation number 1 and talk about its focus, directrix, vertex, and focal width. This point's called the vertex, you know that already. And this is called the focal width. That is the focal width. The width of the parabola through the focus is called the focal width. The focal width. Okay, so let's look at our equation. You are used to maybe seeing parabolas in that form. That is called the vertex form of the parabola. It's a perfectly fine form, it's a function, it's beautiful. But for purposes of finding all this other stuff, it's not the best form. You can do it, but it's just not the best. So if you notice, I brought the 4 over. And then multiplied by 4. And would you agree that that is exactly the same equation, just written differently?
Yeah.
Okay, so where's the vertex? How'd it go, Jane? Oh
That was good. Will you give this to Miss Kors? I don't know how to give it to her since she volunteers.
Yeah, I'll get her, I'll find her.
Thank you.
Okay. So this is our parabola now. The original equation is still there. If you want to use it in that form, you're welcome to. It's the same equation. Here's my vertex. My vertex, this point right here, my vertex is -1, -4. -1, -4. -1, -4. Everybody see where that came from? The vertex? You know enough about parabolas to know this thing opens up. What would it look like if it opened down? You know this. That number right there would have to be negative. that number was that number, it would have to be negative, then it would open down. So this thing opens up, I'm just gonna randomly sketch it in there, it opens up. Now, it's kind of like my example here, so my focus is going to be in here somewhere. And my directrix is gonna be the same distance down. So whatever this distance is that I go up for my focus, I'm gonna go down that same amount for my directrix. Now, are you ready for something really cool? That distance right there, for some reason, is called P. So here's my vertex, here's my focus, that distance is called P. And in every parabola equation in this form, that number right there is 4P. Always. So in our problem, 4P is 4. That won't always be 4, that could be a different number. But 4P is 4, which means P is 1. So I'm gonna start right here and go up 1. So where will my focus be if I go straight up 1 from that point?
-1, -3.
-1, -3. And if I went straight up 1, I'm gonna go straight down 1. Now you're tempted to say -1, -5, but remember the directrix is a line. So this would be the line y equals -5. So if this number had been an 8, for example, then I would have started at my vertex and gone up 2 and down 2. This number is always 4P. And this is always P. All right, last thing you have to find is the focal width. Okay, so here's my focal width. And hang on to your hats, kids, because if you thought it was cool a minute ago, you're not gonna believe this. The focal width is always 4P. That's why I like to have my equations in this form, because this number right here is so very valuable. It's the same as this one, but over there it's 1 over. Here it's just it's 4. So what is my focal width? My focal width is 4. So if I wanted to plot this more accurately, I can start here and count back and forth 2 and get a more accurate picture than the one I just freehanded in there. All right, I don't know why you guys are acting so tired. It's been a great day.
4 hours enough.
I wake up so early.
All right, y minus 3 squared equals 1/8
Let's go.
x plus 2.
How you doing?
All right, it's a parabola, 1 squared term. It's not a circle. Circles have x squareds and y squareds. This only has 1. It's a parabola. It's a little different though, because why? Do you notice anything different about that one? Y is squared. And when y is squared, the parabola doesn't look like this. It opens sideways. So this parabola is going to open sideways. Now, before we start, I'm going to fix it a little bit. I'm going to times by, or actually, no, I'm not. It's ready to go. This equation's ready to go. Looks like this one, just backwards, so I'm ready to go. Here I go. Where's my vertex?
-2, 3.
Yes, very good. Did everybody catch that? -2, 3? Because when you write an ordered pair, it has to be x, comma, y.
So the number that you use for the focal width, does that have to be in front of
The
the
unsquared.
unsquared one?
Yep.
Okay, so if
Yep.
it's in front of the squared one, do you
Move
move
it.
it?
That's what I did over here. Yep. This one's exactly where I want it. So everybody good with a vertex at -2, 3? Now, you've already told me it opens sideways. Any guess which way? That's a positive number there. Do you think right or left?
Go right.
Right. Right's positive, yeah. So you know how up, put this number was positive, so it was up? Well, up and right are the positive directions, down and left are negative. Okay, so where's my focus? Well, I don't know, but it'd be right in there. Does that make sense to you? And to find it, I'm gonna have to go forward a distance called P. And what do I know about 4P? Well, 4P is always that number. So if 4P is an eighth, what will P be? Not a 16. 1/32. 1/32. So I'm gonna start right here, and I'm gonna go forward 1/32. So in other words, I'm gonna start at -2 and add a 32nd. Does that make sense to everybody? Okay, so I can do that a couple different ways. I can either say -1 and 31/32. Would that work? Or I could get a common denominator and say -63/32, whichever way you want to do it. You can use a mixed number, or you can do an improper fraction. Comma, 3, because you went straight sideways, so your y coordinate didn't change. Focus is a point, got an ordered pair. If I went forward 1/32 for my focus, I'm gonna go backward 1/32 for my directrix. This is a line. It will be the line where x equals -2 and 1/32, or -65/32 if you like the mix. It would be an improper fraction. How long is my focal width? 1/8. So I know we didn't go back and forth very far, but that's because this parabola is extremely skinny. Right? It's only 1/8 wide, so it is very, very thin. All right, take this equation right here, a little bit of review here for problem C. Find the implicit equations and graph it on your calculator. Find the implicit equations, the implicit functions, for this guy right here. Find the implicit functions for him right here. He's not a function. Find the implicit functions. And see if you get a really skinny little parabola that looks like this one. Only just super skinny. Are those the equations you got?
Yeah. Why does it like give me a vertex though? It kind of just goes away.
It kind of doesn't join, you mean?
Yeah.
Yeah, that happens to me too. I'm not exactly sure why that is. I think there's a reason for it. I'm sure there, oh, I got a vertex actually. Mine did join up. Did you get a thing opening sideways? It's pretty skinny. Yeah. All right, a couple more and we'll be done for the day. D. Is D a parabola? Unfortunately, it doesn't look like these other ones. So guess what we have to do? We have to make it look like that? Gosh, wake up, honey. What do we do? Well, I don't know. What's your thought?
You can't square root it.
Nope.
Facts.
We gotta find the vertex and focus and directrix and all that stuff, and the equation does not look right. It doesn't look right at all. So here's what we're gonna do. I want you to add the 5 to the other side. Factor out the 2. And we're gonna complete the square. In order to find the vertex, don't we need to have something squared? Here we go. Let's complete the square. Anybody remember how to do that? We take half of this. Half of 3 is, let's use fractions, 3 halves. And then we have to square it. So this is going to be 9/4. Huh?
Can you say how to do that again?
Couldn't hear you.
Can you say how to do that again?
Yeah, you take half of this number and square it.
Okay.
Half of 3 squared. You guys have done that before. Half of 3 squared, 9/4. Here comes the tricky part. If you add, I just added that number over here. If I add it on the right side of the equation, don't I have to add it on the left side too? But that number is in a parentheses, getting times by 2. So it's not really a 9/4, it's really a 9/2. I put 9/4 in that blank, but it's inside of a parentheses, getting multiplied by 2. So the weight of it is 9/2. So that's what has to get added this side. So now I have, I need to add these together. So I have y plus 19/2 equals 2 times, okay, what square is that? X plus 3/2? Think about that for a minute. Our job was to build a square.
Is it 9 over 2 or, oh, you added the 5, never mind.
Now, I'm gonna move the 2 over. And now does it look like I need it to look? Landon? No. If you go out to lacrosse and fall asleep, what is Mr. Gruber gonna do? He's not going to be happy. If you're sleeping in baseball practice, Mr. Freegee isn't gonna be happy, right? This is no different, come on. All right, now it looks the way I need it to look, so let's find the stuff. One more problem and we'll stop, okay? But we gotta finish this one and do one more. Here we go. Where is my vertex? This is my equation. So my vertex, yes, is it negative 3/2, negative 19/2. Which way does my parabola open? Up. I see somebody's back there going like this. Yep, opens up. Which means that my focus, whoops, this one. My focus is right there. Thank you. So here's my focus.
What?
And I have to know how far up to go. So I'm gonna come over here to my equation. And this number right here is always 4p. The number in the equation is 4p. The number I go up is p. So if 4p is a half, I'm going to go up an eighth. So we're gonna start at negative 19 halves, and we're gonna go up an eighth. So negative 76 eighths plus an eighth would put me at negative 3 halves, comma, negative 75 eighths. I know the arithmetic is yucky, it's just how it is. We are, after all, AP students, we can deal with it. If I went up an eighth for my focus, I'm gonna go down an eighth for my directrix. Y equals negative 77 eighths, because I came down an eighth, so that's a minus. And then what's my focal width? My focal width is 1/2. So this is another skinny one. It's only a half wide right here. It's only a half wide. All right, one more problem. Look at E. Backwards. You know the focus and you know the directrix. Now you're going to write the equation of the parabola. I'm going to look at what I got. X equals 11. That's my directrix. And negative 3, 4. That's my focus. And what I am shooting for is an equation that looks like this. So it has, oh shoot, I erased it. It has a quantity squared, and then it has a plain number and a quantity not squared. That's what my parabola equations have looked like. So, tell me what you know. This is your focus. That's your directrix. You know anything about your parabola at all?
It's open like to the negative.
It
and
opens
sideways.
this way. It looks like that. Perfect. Now stop right there. What does that tell me about my equation? If it's opening sideways, which one is squared? Y. And whatever this number is, it has to be negative because left is negative. Now, the numbers that go in the parentheses are the vertex, and that's your vertex. What do I know about the location of my vertex? It is halfway in between those two blue things, or halfway in between those two black things. All right, so for sure, the Y is 4. And what is halfway between negative 3 and 11? 4. Negative 3 plus 11 is 8. Divided by 2 is 4, the average. So, and they're both 4, but make sure you're putting the right number with the right number here, the letter here. Now what's missing? That number. I don't know what that number is, but I know that number is 4p. Always, 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 always. That number's 4p. And I know this is p. So what's p?
7.
7. if P is 7, then 4P must be negative 28. I already marked it negative because I opened it. So that parabola, compared to some of the other ones we looked at, is super fast.
That's not nice.
Okay, so did I give you the homework yet?
No.
No? Alright, so here's the homework,
That's probably
and then we'll figure out which ones we're doing here.
I told Andrew not to take it out.
I don't know.
Kidding. You got
So hard.
Alright, so let's see what we're ready to do.
Oh, shut up. What that is.
Alright, so,
Shout out Mr. Earth.
Let's go, Brandon.
okay, so you are
Shout out
doing
Ernst.
on the homework. Notice, you got A's and B's, you're on both sides here, you know. You're gonna do problems 1 through 4. 1 through 4. When you get to number 5, that will be tomorrow's lesson. So you're doing 1 through 4. And the problems in the homework are like this. Did you swear that? Come on, we don't have kindergarten, not through. You'll find the problems are exactly like the ones in the